Hi everyone. In this video, I'm going to be talking about epigenetics. First of all, we need to define what epigenetics is. Epigenetics is talking about how accessible is the DNA as it's wrapped around a histone. So remember that DNA has a negative charge and that histones have a positive charge. And so they're going to be attracted to each other. Now, when the DNA is wrapped around the histone, depending on how tight that association is, it may be that the RNA polymerase cannot access the genetic code. So the relationship is the more tightly coiled the DNA is, there's going to be less transcription. That is the relationship. So the more tight the DNA is around the histone, the less transcription that is going to be possible. Now then, the opposite is true. The more loose the DNA is coiled around the histone, the more transcription that's going to be possible. And so we're going to talk about how do you change how tight or how loose the DNA is around those histones. And you don't want to change the DNA itself. That would be a mutation. So what we're going to do is we're going to add side groups, or what we call functional groups, to either change the charge of the DNA or change the charge of the histone. And there's two main ways that this process can happen. The first process is called methylation. So with methylation, what we are going to do is add a methyl group. Now the methyl group itself doesn't have a charge, but what the methyl group does is hide some of the charges that are on the DNA or the histones. And so methylation, in a nutshell, we are going to say is adding a more positive charge. Again, it's not the methyl group itself that's positively charged. The methyl group is neutral. But what happens is that the methyl group can hide the negative charges, essentially making DNA or histones more positive. So, if you methylate the histone itself, so remember, histones are already positive, and now we're going to make them more positive. So if you methylate the histone, that's going to result in less transcription. We call this gene silencing, because now the DNA is going to be tighter around the histone itself. But contrastly, if you methylate the DNA, so you're going to be hiding the negative charge on those phosphate groups, what's going to happen is you're going to make the DNA more positive. The histone is already positive, and positive repel each other. And so what you're going to find is there's going to be an increase in transcription, because now the DNA is looser around the histone. So methylation is one way that we can change how tightly wound that DNA is around the histone, because if the DNA is loose around the histone, it's easier for RNA polymerase to access the genetic code, so transcription will increase. But oppositely, if it's more tightly coiled, then there's a decrease in transcription. And so you can add these methyl groups to change how much transcription is going on without actually changing or mutating the DNA. The next example is a process called acetylation. And with acetylation, you're adding an acetyl group, and that is negatively charged. Okay, so with methylation, it was making it positively charged. With acetylation, it's making the histone or the DNA being more negatively charged. So we're going to do the same thing with the histone, and we're going to do the same thing with the DNA. So take a minute right now, stop the video, and predict what's going to happen if you acetylate the histone versus if you acetylate the DNA. All right, welcome back. So hopefully you made your prediction. By acetylating the histone, by making the histone more negative, you're going to make it resist or repel against the negatively charged DNA. So by making the histone more negative, you're going to increase the rate of transcription. Then, contrastly, if you acetylate or make the DNA more negative, so the DNA was already negative, attracted to the positive histones, if you increase that negative charge of the DNA, you're going to increase how tightly wound it is around the histone, and therefore that's going to cause a decrease in transcription. So these are the two methods of epigenetics, which is changing the accessibility of the DNA. I hope this video was helpful. Thanks for watching. Bye.